I've been waiting way too long. Yeah, I've been down here trying to get it. Yeah, I've been waiting way too long.
We're going to look in this video at graphing functions. Given negative x plus 2y equals 6 and the domain negative 4, negative 2, 0, and 2, graph the function. So remember, my domain is my x, so I'm going to make a table because tables are my favorite. So negative 4, negative 2, 0, and 2. So what I'm going to do is I'm going to substitute those in for my x and then solve for y. So negative x, which is negative 4, plus 2y equals 6. Negative negative 4 is positive 4 plus 2y equals 6. Minus 4 minus 4, 2y equals 2. Divide by 2, y equals 1. So that is the output when x equals negative 4. Now, I have a thought here. If I am plugging in 3 other values for x, I'm going to have to solve for y 3 different times. But what I could do is I could rewrite this equation so that the y is by itself only one time, and then I can just plug in and evaluate. So let's do that. So if I want to solve for y, I'm going to add x to both sides. So 2y equals 6 plus x. Then I'm going to divide by 2. So y equals 6 plus x over 2. I could also write that as 3 plus 1 over 2x. Those are the same thing. You need to figure out how those are the same thing. If you don't, you need to ask me. So now I'm going to plug in a negative 2 here for x. So 1/2 times negative 2 is negative 1. 3 plus negative 1 is the same as 3 minus 1, which is 2. If I plug in a 0, 1/2 of 0 is 0, plus 3 is 3. 1/2 of 2 is 1, plus 3 is 4. So now I'm going to plot these points. So that's where those points lie. Now notice the domain was individual points. So that means our range is going to be our individual outputs, 1, 2, 3, and 4. So I am not going to connect the dots because, again, it gave me a specific domain. So I'm going to assume that this is a discrete graph. If they would have told me that the domain is negative infinity is less than x is less than infinity, that means all real numbers, then I would have actually just drawn a line through those points because that means it goes on for infinity. Given the function f of x equals 2x plus 1 and a domain of all real numbers, which can also be written like this, like I just said, you need to know that. You need to know that that means all real numbers. Graph the function. So that means I can plug in anything for x and I should be able to get an output. So again, I'm going to make a table. So let's just plug in, let's just pick some numbers. So if I plug in a negative 2, that would be 2 times negative 2 plus 1, which is negative 4 plus 1 is negative 3. If I plug in a negative 1, I get negative 2 plus 1 is negative 1. If I plug in a 0, I get 1. If I plug in a positive 1, I get 3. If I plug in a positive 2, I get 5. So let me plot these points and see what it looks like. So those are my points, but again, this works for all real numbers. So that means that this is going to be a line, and it's going to extend in both directions forever. So the range, what's the range? Well, it looks like it goes down forever and it goes up forever. So the range is also all real numbers. In this example, we're given a graph, we're given a function on the graph, and we have to find f of negative 5 and f of x equals 9. So f of negative 5, what does this mean? This means what is the value of the function when x equals negative 5? So I'm going to go on the x-axis to negative 5, 1, 2, 3, 4, 5. And I'm going to find where the function hits at negative 5. So if I draw a line, it hits right here. So this purple line represents the function. So the value of that function would be 4. The value of the function at x equals negative 5 is 4. Now I need to find what is f of x equals 9, meaning the value of the function is 9. I need to find x when the value of the function equals 9. So when the value of the function is 9 is 1, 2, 3, 4, 5, 6, 7, 8, 9. That's right here. So that's this point right here, which it looks like is negative 1, 2, 3, 4, 5, 6, 7, negative 7.5.
I've been waiting way too long.